Welcome to another edition of Mac's How-To Tips. Today we're going to be talking about adding a grid-tie solar inverter to help reduce the rising cost of electricity. So this is my solar setup. The power from the solar panels come in here, comes through this meter so I can see the power that the solar panels are putting out, comes down to the DC input of the inverter. The inverter then takes that and converts that to grid power. So right now I'm producing 506 watts out of this unit. This is the grid tie sensor. So it monitors, comes over here to my power panel and is tied to the main line here that comes in, which is line number 2. It'll only produce as much power, won't produce more power than what the grid is asking for. So it will not backfeed the grid. And then the power comes out here. These are just AC surge protectors. This is a little voltmeter. It tells you what the voltage of the grid power is. It's also a timer. So I set it for 60 seconds. So it won't power the grid tie inverter until 60 seconds. So if I get a power hit or it comes back on, it gives some time to make the grid come up and stabilize. You can program it for any amount of time, so I just put it for a minute. And then it comes out, comes up here, and this is a timer, so I turn the grid tie off in the evenings. There's no sense drawing current while there's no sun out. And then it goes into a meter that monitors how much power is going into the circuit. And then this is a special breaker or a plug just for the solar inverter. So I put in another switch down here that ties directly into the grid, which is line 2. One thing I learned about breakers is this is not all line 1 and this is not all line 1, 2. They rotate. So this one might be line 1, line 2, line 1, line 2, line 1, line 2, and so on for each side. So if you're going to tie into it, you need to make sure you understand this breaker right here was actually on line 2, the main line that was coming in. So I have 2 lines plus a ground. So you can actually see the current drop on line 2 when the grid tie inverter is on. So that's my setup. I'll provide a little more detail on the parts numbers coming up. So here's my solar panels. They're 420 watt panels. Each will put out about 8 amps of current, so they're in parallel. So the wire comes down, they connect, and then it comes down and then down to a circuit breaker here. So you need to have a way to cut off your solar panels if the electric company needs to work on your meter. And then I'll also have an AC surge protector here as well to protect any lightning strikes. And also you need to make sure you have a good ground wire that comes in and ties into your main ground that you ground your solar panels to. The solar panels I picked were the Q-Cell 420 watt panels. I found a dealer just south of Dallas, about 40 minutes away. You could pick them up for $95 each, so that was a really good deal. The key here is matching your open circuit voltage, the VOC, as well as the current. Make sure you match that to the inverter you select. I picked a 1000 watt grid tie inverter off Amazon for about $324. You can find them cheaper on eBay, but I ran into some problems with a seller there, so I ended up purchasing this one. It comes with the limiting sensor, so again, that attaches to your main line, either line 1 or line 2, depending on which one you want to monitor. And then it will limit the output of the grid tie inverter to not deliver more power than what that line is requesting. I didn't want to deal with the power company and feed back anything onto the grid, because with the smart meters today they can detect that, and then you end up paying extra. So here's a close-up picture of some of the parts. The top one there is the meter that I talked about. You can program it to delay the power on to the grid power inverter. I set mine for 60 seconds. the AC surge protectors. They're TZG40Cs, and I'll put all the part number listings in the description below. The inverter actually has a panel on it that you can flip two different screens. The one shown here is the main power. So you can see when I took this picture, it was delivering 923 watts, almost 1,000 watts. That was in the middle of the afternoon. And the little 123.5 volts, that's the grid power. And then of course, additionally, from the grid, I was pulling 163 watts in addition to the 923 the grid tie was producing. The meters in the middle there, that's the inputs, so it should fairly well match. That's the watts and current. And then how I monitored the line 2, you can see the two readings there, one with the inverter off. This was done a little bit later. You can see it's measuring 8.51 amps, and then once the inverter kicked on, it dropped to 3.6 amps. So that's how I knew which line the breaker was tied to. So here's a listing of most of the parts I used. I'm not going to read them all, but I'll leave the screen on here, and I'll also put all this in the description below. I did have some optional stuff like the surge breakers, or the surge protectors, the arrestors, the meters. You don't need to do all that if you want to be more cost effective. And then I had some stuff from previous projects, conduit, cable connections, AC plugs, boxes, breakers, that type of stuff. And some pegboard. So I mounted all my stuff on the pegboard so I could easily move it around or add things later on. Well, that's about it for my setup. I hope it helps you with yours. I'll come back at a later time once it runs for a while and talk about performance and cost savings and things of that nature. But happy project time, and I hope it helped you out.